to like 90.
Okay, well, this is 60 right here.
Yep. So that's
This
really
is
predominant.
This is the predominant direction.
So that's
So we have a
coming in
little
from
bit of a wind
the
tunnel
east.
going on through the main street.
Yeah, it's straightening up there.
Yeah. And what happens is that the lower parts of the building inside the courtyard is getting shadowed.
Here's what's happening on this side.
Yeah. This is the predominant direction, you said?
60 is predominant. And in terms of temperature, it's warm. It's not the warmest.
I see.
It's moving.
Yeah.
It's not completely shadowed.
Yeah.
It seems like that gap, the gap up to the north, is actually nice.
But the worrisome part is that the predominant facades of the building are parallel to the predominant direction of the wind.
Close
Yeah.
parallel, yeah.
Yeah, that's it.
I think if we keep going to 90 and 135, we start getting more interaction with this building. So the mass of these buildings over here tends to, I think.
Okay, so here's 90. Well, put it on top of the building right next to
Well,
it.
so this, yeah, I'm going to go kind of far away and close by because this is sort of the site effect as the wind is hitting the buildings and coming up. It's going to be going this way.
Yeah.
That's coming
So we have a
south.
big wind shadow in the courtyard at this point.
Yeah.
Yeah,
That's south.
Let's put it also on the leeward side. And you slide it in there just so it's exposed to the enemy.
Sakamaki.
Oh, there's some motion
You can
there.
see it, so there's some
But it's,
editing that's happening.
But also there's some pulsations at that point.
Yep.
it's moving pretty fast with the pulses.
Well, what happens is that the courtyard gets pressurized and then it reaches a certain threshold and then releases.
Yep. So it's really the air is moving up, but this is the first open area where there's an opportunity for the air to move back down.
Yeah. So, and there it goes, yeah. So I
So
thought
it may be
another
okay.
direction was from here.
Let's keep going to 135. This is let's see, so this is the one where this would be directly upwind. It's a less frequently occurring direction, but the weather is typically warmer. That seems to be moving around. I think it's kind of channeling in through the building. Over there. You aim it a little more to the right. Yeah.
You know what's interesting is that there's a little bit of air coming. I wonder how accurate this is. There's air coming from underneath the building and pushing the smoke out.
The office.
Yeah.
There is an open space on it.
Yeah, because of the
Pretty large open space in that office right now.
Yeah.
It's wide open.
yes, yeah.
There is
But we're
interesting,
proposing to enclose that. But
Oh, you are?
yeah,
I see. I see.
There's some interesting pressurization that happens in that kind of in there.
Yeah, because the smoke can't get anywhere near the building. There's air also coming in through the side over there and just. Oh wow! Look at the downdraft.
Yeah,
Just was done.
it's coming over something.
yeah.
Well, that's good news because that means that the building is being. There's a lot of pressure against that facade.
Yeah. So in terms of interpreting this, I've kind of come to realize about this. So this thing is actually causing air velocity coming out.
Yeah, right.
So it's in some ways you need to be suspicious, but what happens immediately after this hangs out is something you can truss, like how the stream of water vapor is being
Okay, so if you
modified.
pull it back here, if you hold it out here,
Even when you had it in there, if it was being whisked away in a particular
Oh,
direction,
yes,
that means
that's
there's
the
airflow.
actual-
Yeah.
yeah, it's such a long drop.
Yeah. Interesting. Okay. And then, so then I think the other directions are less of a concern. Once we go to 180, we start getting more into an exposed area where you have
So what's
Less disturbed airflow.
what's frequency of 180?
so from after you get past 90, every direction is pretty much equally frequent,
Oh, I see.
and it's not that frequent. But the temperatures are highest from between 90 and 180, and 90 and 270.
Oh, I see. Well, that's
And-
good news.
Yeah, from 270 west to north, it's pretty. It starts to get a little more frequent, but that's by far the colder weather.
Okay.
Does this match with experience at all in terms of what you experience on campus?
The wind is coming from where?
From the northwest, does it tend to be cooler?
Yes.
Yep.
Yep. Any wind that's coming from the south is considered to be Kona winds. It's coming from off the ocean, fairly warm temperature coming in from, say, Guam, kind of closer to the equator.
Yep.
And that's warm. So
Those are the
it's
hot-
really
that's the hot one.
hot.
Yeah.
And it comes into with fog from the Big Island, and that's a cool challenge. It's very humid. Thick.
So then, if people, so that we can test other directions too if people want to see other directions, or revisit any of the other ones. To kind of summarize this model, what we're seeing in terms of the movement of air is good to kind of develop an intuition about what's happening on the site. But the pressure readings will actually tell us the ventilation potential at any of these particular directions. So because we've recorded all that data, we don't have to be concerned with. It's good to know that there's a downdraft. It's good to know what's going on with the building at this site. But really, what's going to drive ventilation at a particular floor, let's say of the office tower, is that downdraft creating a positive pressure here? How much? We can measure that all the way around. Once we figure out what the pressure differentials are all the way around, we'll be able to know how air moves through that. And so the focus of the next model that we'll look at, the bigger model, is to actually see how air flows through a space given a certain pressure differential. Any questions, thoughts?